Hello, good evening, everyone. Just to prompt you, this is a recorded meeting, so I hope we have your permission to record it. As we said last week, all our meetings will be recorded and posted on the website so that people can follow up. So this is always going to be a recorded meeting. Thank you very much, everyone, for showing up. Welcome to the engine where we are going to train the masses in Africa and around the world to be able to use different tools for their work. What we are starting with now, what we are starting with now is machine learning training, and this is offered for free. So this is a machine learning course that is for free, and is going to run till December. Then you can graduate and get your certificates. Now, the certificates are going to be given based on 3 assessment rules. Number 1 will be the attendance of lectures. You have to attend about 80% of the lecture here and be interactive. And then we are going to have a mini projects. We understand we have different people with different backgrounds in agriculture, in materials engineering, in mechanical, civil, in all aspects, all aspects of engineering. So we are going to group us into different categories and different groups. We're also going to have a group on finance for the humanities folks and business folks that are among us. So these groups will be given tasks based on the various lectures to organize yourselves and organize data and actually do machine learning in this course. And you would have to submit your project along with a test. You're going to have a cheap test, as I would say, just fundamentals of AI and the things you'll be hearing today, and the rest of the lecture will can everybody hear me? Somebody says you can't hear me. Just give me a thumbs up if you can hear me.
We can hear you.
Yeah,
Okay.
we can hear you.
All right. Thank you. Yeah, so we are going to, you're going to do a test at the end of the day in December. And whenever you are ready, you can come to the system, write the test, and then when you pass, your certificate will be sent and emailed to you. So this is going to be an important part. Without wasting your time, the teacher for the class is here. So Dr. Elvis Chumesi, if you're around, just share your screen and prepare yourself for the lecture. All right, so I leave you in a scare. I'm going to post the forms for attendance in the link for the forms in the chat. And so you can simply click on it and just go there and fill. It's just 3 questions there, just your name, your professional code, and then you tick present. And so I'm pasting it in the group. So you can just go there and just choose present for us. Just enter your code, enter your name, and just say present. And this is what the certificate is going to be based on largely. So let's all go there. I'll be posting it from time to time in case people join late so that you can go there and do it. So I'm going to mute myself and hand you over to Dr. Chumesi. Dr. Chumesi, please go ahead.
Okay, thank you very much for this great opportunity, and thank you for having me. I'm glad to start this introductory course in machine learning AI.
Please, can
And I
you
want to welcome
introduce
all of you to the
yourself a
engine.
little bit to the group? Introduce yourself, your background, so that they know the teacher they're dealing with tonight.
Great. So you're all welcome to the engine, and we believe that this course that we are going to have is going to be as practical as possible, and you are going to grasp almost everything that we are going to do, especially in this course. I'm Dr. Elvis Chumesi. I'm a lecturer at the Kwame Nkrumah University of Science and Technology in Ghana, and I'm also a research scholar at the SUNY Polytechnic Institute in US currently. Yeah, so I'll be taking you through the first course, and as time goes on, various lecturers and various teachers will come to us with respect to various aspects of AI machine learning so that we all have understanding. As discussed earlier, this course is going to be practical. What it means is that all of us will be given a project and we are going to go together with the project. And whilst we teach, we embark on that project. And by the time that the course the course ends, we'll all have finished the project. So let's say you are taking a project where you are detecting breast cancer in women and all that, and you are supposed to use machine learning to do that. Throughout the course, from beginning, as we show you how to prepare your data, you prepare the data. As we show you how to clean your data, you clean your data. As we show you how to go about the machine learning models and all that, then you'll be doing that alongside. By the time the course ends, you would have finished a whole project that will be so meaningful, especially to Africa. Yes. And I believe that everything is going to be simplified, especially in this. When it comes to AI machine learning, it has become the talk of the day. Everywhere you go, AI machine learning. And a lot of people feel left out in terms of they are looking at, do I understand this thing? This AI thing looks mysterious. And do I really understand? But one thing I want to start with is that actually AI is something that all of us actually knows. So far as you've been through any basic education at any stage, it's something that you've been taught in a way, just that now it has been packaged in a new area for all of us to look at. So I just want you to know that actually you have a fair understanding of what AI machine learning is, just that maybe because you've not gotten time to actually look at it, you feel as if you are left out and you don't have any understanding in that area. And as I go through this course today, realize that most of the things are things you've heard before, just that we've clustered it within a certain section where we are calling it artificial intelligence and machine learning. So to start with, I want to, and this is an introductory course for us to know everything about what we will be doing, especially in this course. And by the time you leave this course, you should be able to know what machine learning is, what AI is, and almost everything about AI machine learning. You should just have a fair idea of almost everything so that as time goes, we'll be looking at them one by one for you to get the details about it. Now, most of the time, the word machine learning AI has been used interchangeably. And when you go online, you go to YouTube, you want to know what AI is, what machine learning is. Everybody has his own understanding of what AI, what machine learning is, and whether they are the same, whether they can be used interchangeably. And there are a lot of similarities, right? But one thing I want you to understand is that machine learning is just a subset of AI that allow computer to learn patterns from data and also make decisions or predictions without being programmed. Like in those times, you have to program almost everything for the computer to do. If it is 1+2, you have to program everything for the computer to do. But with time, we want to be able to let computer learn from data and be able to make predictions or make decisions without we programming and doing a lot of things. So basically, that's what machine learning is, just a subset of AI. So AI is provide the reasons and answers to questions about a system that has been trained on. So just take an AI to be a big umbrella, and you have machine learning as part of AI, and we have something we call deep learning, which you have also been hearing, also as a subset of machine learning. So we have AI as a big umbrella, we have machine learning under AI, and we have something we call deep learning, which is under machine learning as a subset. Now, for us to get the understanding further, I want you to think of AI as the goal. Like we want to achieve something in terms of making machines think like human beings, right? That's why it's artificial intelligence. Machines are artificial things. And then we want them to have intelligence just as human being has. So it's the main goal. We want machines to think like human beings, right? But how will we get machines to think like human beings? We need machine learning as the method or the tools that can help computers to think like human beings. So that's how I want you to see what AI, that's the main goal. We have, let's say, a robot. You want the robot to act just like as a human being would do, just that the tools, the things that will cause the robot to be able to think like what human would think, is what is called machine learning. So it's just a subset of AI. So machine learning, AI means creating smart machines to mimic human behavior. But machine learning is a subset of that AI that will build models and that will be trained on data to make predictions. Then we have what is deep learning, and deep learning is just a subset of that machine learning, which we'll look at as we are going forward. That actually is looking at how we can build bigger models, which are also machine learning models, to also do things that human beings can actually do. Now, sometimes you hear of data science. One thing is that you cannot do AI, cannot do machine learning, deep learning without some form of data science. What it means is some little statistics and some little understanding of what data is, what information is. You want to know what mean, average, median, all those little things that we use to learn. All those things is what is grouped under data science. And definitely, if you want to do AI, you need some data. If you want to do machine learning, deep learning, you need some data. So these words have been used interchangeably, and that's why I've provided them as a subset. That AI is the main umbrella, machine learning is under it, and some part of machine learning is deep learning. And I want to show here, as we are still depicting what AI, what machine learning is, because I'm sure maybe still it's not clear what is AI, what is machine learning. We are still seeing AI as the goal and machine learning as the method. So just see AI as just this big circle, and something like robotics, right? Computer vision. And now, as an example, let's take a robot. You see, before we can let a robot think like a human being, the robot needs to see. Now, seeing is not machine learning. Seeing is just something like computer vision. For you to know that this is a car, like as you are looking at this screen, you can see a circle. How do you get to know it's a circle? First, you need some sense of sight. You need some form of sensors to be able to see. So sensors, computer vision, they are all has to do with AI and has nothing to do with machine learning. You're seeing, you're sensing, but the question is, as you see the thing, how do you interpret to know that it's a circle? You need a machine learning algorithm to understand that this is a circle. So realize that AI is just machine learning, but the brain, machine learning is just the brain of AI. Just that AI may include a robot seeing something, and as he sees, or there's a sense of feel, you touch something. As you touch, how do you know you felt something? You need a machine learning algorithm to understand that, oh, I felt this, I saw this is a car, or this is a dog, right? So the seeing part is not machine learning. The feeling part is not machine learning. And then the making of the robot itself is not machine learning. But the brain of the robot to be doing the thinking is the machine learning. So realize that machine learning can just take it as the brain of artificial intelligence. So artificial intelligence will include computers seeing, robots seeing, like a self-driving car. As the car sees the things on the way, that's not machine learning. As it sees that this is here, or this is the road. Should I pass here or should I? The decision to say, should I pass here or should I pass there? You need machine learning to make that decision. So all the decision process is made with machine learning, but all the other things like seeing, feeling, and all the nitty-gritties about the entire system is what we are calling AI. So it means that you cannot do AI without machine learning. Just like you have seen a car and you can't interpret that it's a car. You need machine learning to interpret. So it means that you cannot do AI without machine learning. So basically, that's why most of the time it's used interchangeably. So let's look at in a short way how to distinguish between what is AI, what is machine learning. So AI, in terms of the scope of knowledge, AI is a broad scope with some theoretical consideration, and it's trying to simulate human intelligence. But ML or machine learning the scope is narrow to the algorithms and the models that will make the human being the machine to be able to think like a human being. And mainly, I think the idea of the approach to solving problems will distinguish between what AI and machine learning is. You know, when we talk about AI, it's not everything about AI that is machine learning, but everything machine learning is AI, right? So now, if you want to solve problems, We have things that we call something we call expert systems or rule-based systems. You know, in science, we have something called fuzzy system. You know, that we can decide to solve some problem by trying to develop rules to decide that this thing is this or this thing is that. If maybe the thing is a circle and we can eat it and it's on a tree, then we can say, oh, maybe that's an orange. So you see, that thing is not machine learning. We are just trying to develop some form of rules to try and understand something. So you could see that here I could solve a problem of deciding what is a mango, what is an orange, not by not even using machine learning, by just using some rules. So that one will be under the umbrella of still AI. But then if I want a system to be able to pick up data for a long time and train that data and make decisions from that data, then I know that I need something we call machine learning. So AI includes all problem-solving capabilities of machine learning, plus additional methods like expert systems, like fuzzy systems, like rule-based systems, that necessarily does not need data to do that work, right? So, but ML will learn from data to create the same kind of models and understanding. So when it comes to the level of human intervention, when we are dealing with AI will have some non-machine learning systems that will often depend on human configuration. So if, let's say, you want to do something based on some rules, then you need some human being to be able to give you the necessary rules. Like, say somebody is in the hospital, if somebody is sick and is in the sick bay, like those things that we used to learn about logical reasoning. So just take logical reasoning as part of AI, and machine learning is just the core. So machine learning, logical reasoning, all together is making up artificial intelligence. But most of the time, because most of the decision and rule-based and expert system need more of human intervention. Almost everything about AI is moving away from there, and everything is just moving to, let's use data, let the system learn by itself and get the understanding. So basically, that's what the difference between AI and machine learning is. I hope I've been able to convince you on what AI and machine learning. So it means that we need to focus more on machine learning. Anytime we are talking about AI, we are basically talking about machine learning, because it's the brain, is the one that's going to do the thinking, the one that's going to do the job, right? Now we have different types of machine learning. We have different types of machine learning, and basically I put machine learning into three types. We have something that we call supervised learning, unsupervised learning, and reinforcement learning. So you should know this by the end of the class, that we have three types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. What it means that, machine learning has to do with, that's why it's learning. We have to learn data and decide to make something. So just think about we making a robot. A robot is like, when you make a robot fresh, it's like you have just given birth to a child, right? Because the robot doesn't know anything and you have made it. And with time, you want the robot to be able to interact with people and know what the difference between this and this is. Realize that when you give birth to a child, from the beginning, the child doesn't know anything, right? So most of the time, the child with time will try to be able to look at his environment to try and learn something. So reinforcement learning mainly has to do with a child who does not know anything and he is in a certain environment, and as he moves through the environment, he'll be able to be gathering some data to know this time I'm supposed to do this time I'm not supposed to do this, and all that, right? So now let's take a child who maybe wants to know the difference between a knife and toffee, right? Now, if the child is in the kitchen, he doesn't have any data yet. He doesn't have anything to tell him, oh, this is a knife, this is a toffee. But then see, as the child puts the toffee in his or her mouth, the child feels, oh, this thing is nice. So the next time he would want to go to that thing. As he takes the knife and the knife cuts him, he realized that this time I'm not supposed to take that knife because that thing can cut me. So you see, realize that that's why we call them reinforcement learning. As time goes on, the child starts picking things from his own environment and start learning by himself, right? And start learning by himself. But realize that most of the time, when we lead children to learn by themselves that way, in terms of reinforcement learning, we need to tell them, don't go here, this time go here, don't go here, this time go here. It means that actually, if we were supposed to teach them what to do, basically they will be able to do the thing so easily. So now let's take what supervised learning is. Supervised learning is basically looking at a child that you want to train, but then you are training the child by showing the child examples. So let's say you want your child to be able to know whether this is a dog or this is a cat. Then what it means is that you start showing your child what a dog is. So when you show the child this dog, then you say this is a dog. Then you show the child a cat, then you say this is a cat. So you realize that supervised learning has to do with when we give data to something, or when we have a certain data, we have the corresponding output to let the person know that this is it. So we have an input, which is a dog, or some characteristics of a dog, which are the inputs, right? And then we have the dog itself to show the child that this is the dog, right? So anytime we have some characteristics and we have the corresponding output to it, we call that supervised learning. So as I show maybe the ear of the dog and then the ear of a cat, as I give that characteristics to my child every day and tell him that, oh, this is a dog. The next time I say this is a cat, depending on how the ear is and how the whiskers are. So as you give the child different characteristics, you show the child what it is. And because you are giving the person the output at the end of every learning process, you say that you are doing supervised learning. Like, let's say you are supervising somebody. It means that you are showing the person that this is this. So we have characteristics of dog, and then we have the dog itself to show that this is a cat or this is a dog. That is supervised learning. So what it means that any form of machine learning will be in these three types, right? So most of the time, the best way for us to teach people and for us to even teach a robot on what to do almost every day and will never make mistake is when we use supervised learning. It means that we'll show the robot several dogs, several cats, and then the robot with time will be able to tell that this is a dog and this is a cat. Now, just as your child, at some point, you show him a dog, sometimes he might say it's a cat. You show him a cat one time, and then that cat looks like a dog. He might say it's a dog, right? Maybe it's a puppy. So he might say it's a cat. Now, that one is actually showing that you cannot be 100%, especially even if you are doing supervised learning, you may not be 100%. But at least by some 99%, you are sure that with time, you'll be able to get your child to be able to distinguish between a cat and a dog. And that is supervised learning. And you have unsupervised learning, where let's say, for instance, you've given your child characteristics of a dog and a cat, but you've not shown the child a cat and a dog, and you just want the child by himself or herself decide whether it's a cat or a dog. That would be more complicated. Let's look at, you give your child red balls and green balls, and you've not shown the child which one is red, which one is green, and you're giving that to the child to try and separate it. Just say separate it. Whether you not say maybe put the red one as one side or green. The child even doesn't know which one is red, which one is green. Now realize that with time, as the child is sitting there, so you've given the person an input, but there is no output. You've not told him which one is red, which one is green, right? But realize that with time, as the child is playing with the thing, he or she will be grouping the one that she sees to be just alike and the one that she sees to be not alike, right? And that is unsupervised learning. You've not shown the person this is red, this is green, by just giving the person a group of a lot of balls, and you want the person to decide which one is green, which one is red. And realize that unsupervised learning, sometimes you may have to go through a lot of things before you be able to get a child to get to know that this is red, this is green. But if you are shown the child, this is red, this is green, this is red, this is green, so group it, you do it so fast. So that's why most of the time we want to go with supervised learning in terms of almost everything that we want to do. So every time we want to gather data where there are inputs and there are corresponding outputs, supervised learning. If you gather data where there are inputs, no outputs, unsupervised learning. If we have to let the system try to gather data by itself with time, then it's just like take a self-driving car. As the car is moving, let's say as the car is moving and starts going to the other lane, there should be some system to say, we call something rewards and all that when it comes to reinforcement learning. As the car maybe have an accident, you say that, oh, you didn't do well as a negative. Then as the car goes in the right direction, you say, oh, you did well. Just like how you are teaching your child, and then the child doesn't know any data, but you are just using, oh, you are doing well, you are not doing well, you are doing well, you are not doing well. The child will know which one is good and which one is not good with time. That is reinforcement learning. And these are the basic three types. And now we are introducing more of something we call semi-supervised, which is in between supervised and supervised. But mainly, we want to talk about supervised, unsupervised, and reinforcement learning. Good. Now let's look at reinforcement learning. Now output. Then there are various ways. There are various ways that you can go about it. Now, supervised learning is clustered into two types. We have two types. If you have a data where you have input and you have the corresponding output, there are two ways you want to go about it. The first thing is whether you are doing something we call classification or you are doing something we call regression. Classification is basically looking at whether you are telling this is A or this is B. You are telling, just like, so if I give you a certain data and I want you to tell whether this is a cat or this is a dog, it means that you are classifying, right? So if you have a supervised, you have a data and you have the input and output, there are two things you may be doing. Either you are classifying or you are doing something we call regression. Classifying means that you want to tell the class that that thing is. Is it a cat or is it a dog? So if I'm doing any work and I'm telling, is it a cat or is it a dog? Is it a disease or is not a disease? Is it HIV or is not HIV? Then I say that I am doing classification. But if I want to tell how many people or the price of electricity tomorrow, I will not say that I'm classifying. I will say that I'm doing regression, right? So the word regression here is not a regression you know, but rather it's just a term to talk about. So some people mostly use the word prediction. So classification and prediction or regression. So regression means that maybe I want to tell, now as soon as I want to tell, would there be rain or no rain? Classification. How much of rain will come tomorrow? Regression. So these are the two different types of supervised learning that we have, classification and regression. Then we have unsupervised learning, and mainly also in various types. We have something called clustering and dimensionality reduction, right? And most of the time, most of unsupervised learning is mostly used for clustering things and all that. Now, for instance, as you are watching Netflix and all that, how do we know the type of movies that you like, right? How do we know that you like this one? And you see, there's no data from you to tell that you like this or you don't like this for it to be supervised. But I realize that as you keep watching this movie, you keep on watching this movie, you could start recommending which one you like and which one you don't like, just by looking at the ones you are watching and then trying to group them. So there's difference between clustering and classifying, right? Now, if I have a group of balls like red and green balls, and I want to tell which one is red, which one is green, then it means maybe, and then I have data that shows that this is red and this is green. I can say I'm doing classification. But if I don't have any data to show that this is red and this is green, but all that I know is I have a lot of balls, but I just want to separate between red and green, I'll say that I am clustering. I'm not classifying, I'm clustering. I'm trying to find my own way of dividing the green and red balls on supervised learning, and that is under clustering. But if I was shown this is red, this is green, and I want to tell whether this is red or this is green, then I'm doing classification. Good. So you realize that under clustering, we can do recommended system, customer segmentation, and as we go forward, we'll be talking about almost all these things. And when we talk about reinforcement learning, self-driving cars, robots, and all that, we will let them be learning in their environment with time, and then that will be under reinforcement learning. So what it means is that most of the things that we want to do supervised learning. We want to get data where we know the input and output, because that one, we are sure that we have examples that we can tell with time and be able to do things so easily. Now, let's look at, so supervised learning involves training models using labeled data sets. You have the input and the output to make predictions or classify data. So there are two things. Either you are classifying, doing classification, that's under supervised learning, or you are doing regression. Now, if you want to do classification, you want to classify things. This is a disease, it's not a disease. There are some models that, as we go forward, we will introduce to all of them, right? We introduce to all of them that we use for classification. And there are some models that we use for regression, that is making predictions, right? In terms of quantity. In terms of quantity, what is the price? What will be the price of this building? Is this a red building or a yellow building? Classification. What will be the price of this building? Regression. So there are various models that we can use depending on whether you are doing classification and regression. As we go forward, we'll let you know which ones you can use for classification, which ones you can use for regression. Realize I have something called logistic regression, which I'm sure you've heard about it before if you have done any form of statistics before, right? This mainly is for classification work, and you will not be able to use it for regression work. And we'll explain with time what that means. We have models like decision tree, random forest, k-nearest neighbor. Now, some of these models, you can either use them to classify things or doing regression things. And you can, so basically these models are general models that can be used in any way. Then under regression, we have something called regression. That's the linear regression you know. So the linear regression you know is, and actually almost everything machine learning is based on this linear regression. The linear regression we learned almost at every stage of our life, how to draw a line of best fits. It's basically the import of almost all machine learning models. So under regression, the models that we can use, we have regression, should I put linear regression so that you know that it's not just regression. So regression is the main idea of predicting something, but the model that we need under them, we have linear regression, we have decision tree, random forest, k-nearest neighbor, support vector machine, talk of XGBoost, and all the other models will be introducing you to. Then we come to classification, we have logistic regression and decision tree on, and these models for them we can use in both sides. Then we have something called unsupervised learning, which I've also explained. It's either you are doing clustering or dimensionality reduction. And if you are doing clustering, there are various algorithms so that you will need under clustering. We have something called k-means clustering. We have fuzzy clustering, we have hierarchical clustering, and all that. And under dimensionality reduction, we have something called principal component analysis. And we will be introducing you to them because we will have a whole course that is actually going to look at what is supervised learning and what are the models under them, what are unsupervised learning, and what are the models under them. And then we'll do practically. So depending on the problem that you are solving, you will know whether you are using unsupervised learning or supervised learning. Now, let's see how you can build any machine learning work, right? So let's look at the machine learning process. So now I'm sure you have a fair understanding of what machine learning is. You just need data. Now, if you have the data, you have the output to it, then you say that you are doing supervised learning. If you have the data, you don't have the corresponding output, you are saying that you are doing unsupervised learning. If you want the system to start gathering data by itself, then you say that you are doing reinforcement learning. So basically, most of the things that you'll be doing, you would want to be going for supervised learning, where you have, maybe you want to predict the prices of phones, right? So you should know the type of phone. So if you have the type of phone and you have the corresponding price, then you know that you have that supervised learning. So you have different types of phones with their corresponding prices, and you want to predict the price of something, then you are doing supervised learning. But you have the various types of the phones, but you don't know their prices, but you just want to be able to tell the price, then you are doing unsupervised. And you realize that that will be a little difficult to be able to tell price in unsupervised learning case. So most of the time, we want our data to be supervised. It means that we want the corresponding output. Now, in machine learning, your data that you have, what it means is that every time you need to separate your data into what is your input and what is your output. How will you know your input? Your input are the things that describe the thing that you want to do, and your output is the particular thing you want to do. So the type of phone and the price, and you want to predict price of things, then you know that your input are the types of phone, and the output is the price of phone, right? So now your input, instead of saying inputs, I always say that almost in every field, we just try to change names so that we'll get people to come and learn it and get understanding by something that we know. So inputs, instead of calling them inputs, mostly in machine learning, we call them features, right? Features. So when you hear of features, these are the features of my data. It's basically the input of your data, right? And then your output, we call it labels. Call it labels. Or sometimes we call it the target. Instead of saying output, we say the target. That's what I'm targeting. Or that's what I've labeled this thing as a dog or a cat, right? So your inputs are your features and your labels are your outputs. So anytime you have your data, you have to separate it into features and labels, right? So that you know these are the characteristics, this is the corresponding label to it. So your inputs and your outputs. Now, when you get your input and output, every time you will need something we call a machine learning model. And that is the types that I've actually introduced you to: the linear regression, the decision tree, the random forest, the support vector machine. You need a certain model, which will introduce you to almost all those models that you need here. So every time you need your data, separate it to what are the inputs, what are the outputs. You need a machine learning model that will be able to understand. So what we are going to do to this model is that anytime you show the model the input, then you will show the model the corresponding output to it. So let's say you have data where you have x, x1, x2, and the output is y. So now when x is 1 and x2 is 1, then I'll say y is 10. So I'll be showing the input to the model and the corresponding output to it. So with time, this model will get to understand that. So just take a black box where the input is x, the output is y. You put 1, you get 2 outside. You put 2, you get 3. You put 3, you get 4. You put 4, you get 5. Then you realize that, oh, and inside this black box, there is a certain equation there called x plus 1. Because any x that goes inside, it adds 1 to it, right? And the thing is that, so what means that this model with time, as you show him input, output, it will build up a certain equation within here. Sometimes it may not be an equation, to be a set of some rules and all that. To build that in here so that anytime there is any new input, it will be able to tell what the output is. So when that model is fully built, then you say that you have actually built a machine learning model, right? Then you take that model, you come and use it. What you do is that you can now go and take new data, new features, and when you come and give without labels, when you come and give them that to the model that you have built, it will be able to predict the corresponding label to it. So that's basically everything about the machine learning process. Get your data, separate it to input and output, give it to a certain model. The model with time will learn, then pick the model, and anytime you have any new input, give it to that model, it will tell you the output. That is all. So the basic thing we need to know is, how do I know which one is my input, which one is my output? Then the next thing we need to know is, what are the various models I can use? Because our models may be able to understand some data than some models. What are the various models I can use? Then when you get to know that, that's all. You built a model and you give it new data, and every time it will be able to do the work for you. Basically, this is any machine learning process. So if you want to do, like with respect to the project that all of us are going to do, if you want to use machine learning, it's not difficult at all. You just first of all need to structure what your project is about. Maybe you want to predict whether something is a breast cancer or it's not breast cancer. You need to understand what is your goal. Everything about machine learning first. The first thing is, what do you want to do? Do you want to classify, or you want to regress, or you want to predict? Okay, I want to tell whether this is cancer or it's not cancer. I want to do classification. That's your goal, right? Then choose the solution to your problem, how you want to go about it, right? Then the next thing that you need to do, which is the most important part of machine learning, and it's mostly the one that will take almost all your time with this machine learning thing that we are taking you through, is something we call data preparation or data pre-processing. Because sometimes when you gather data in real world, they are scattered, they are noisy, right? There are a lot of things. Maybe you are letting a sensor pick some data for you. Sometimes the sensor will bring the data, sometimes the data will not be ready. So you need to structure the data very well to get your inputs and your outputs before you can do anything, right? So that's data preparation, and you'll be introduced to that. You have to gather your data, and sometimes there are some comments. You know, one thing I want you to understand is that machine learning, everything is about numbers, right? Everything is about numbers. So you gather data where there's a question mark, there is a comma, there is something, and before you can use it in any machine learning model, you need to make sure you remove the comma, the question mark, and all that. And that's what we are doing as we are pre-processing your data, just to make the data look well. What it means is that anytime I give you data and the data is well structured, you don't have any difficulty with machine learning at all, because all that you are going to do is to give it to a certain model and it will make the prediction for you. So we introduce you to data pre-processing and everything within this stage. Then we also introduce you to something we call splitting of the data. I'm sure as I go forward, I'll be talking about them one by one. Now, one thing is, as soon as you've gathered some data, you want to give the data to your model for your model to start learning. So let's say you've gathered 100 data. and you want to give it to a machine learning model to make prediction for you. One thing is, you don't need, if you give all the 100 to the model to make prediction for you, how will you be able to tell that the model is doing the right thing or is not doing the right thing? So every time, any data that you have to split the data. You have to separate it into two things that we call training and testing, which I'm going to introduce you to very soon. Good. So let me just give a general thing. You split your data, then you give it to a model, you go through some process, which I'll introduce you to very soon. Then after that, you can deploy the model to use it for what you want to use it for. So every machine learning process, you define your problem. I want to do this. You start gathering data about it. You have to do something called feature engineering, know what your features are, and then do some and test which of the features are good, which of the features are not good, which will introduce you to more. And then you select a certain model for it. Then after that, you split your data. So as I was explaining, instead of 100, giving all the 100 data to the model, when you finish, how will you tell whether the model is doing the right thing or is not doing the right thing? So every time you split the data into two, right? And most of the time, you want to give the model a lot of data so that the model will understand the thing that's the data that you have given it, right? So the one that you give to the model for the model to start understanding is called the training data. And then you also, the rest of the data that will be left, you use it to test the model to see whether the model is doing it right or is doing wrong. Good. So mainly you split your data into training and testing. Other things will come in and we'll be introducing you to them very soon, where we'll be trying to tune the model, and I'll speak about that. Now, after giving your data to, let's say you have your data, 100 of them, and you are saying that you are using 70 of them to give to the model for the model to try to understand the data. After you finish, you now have your trained model. And as you are going to, before you can deploy the model, you need to test it. As you give the tested data to the model, you need some metrics. You need some things to check that the model is actually doing the right predictions or not. So you need to do something called validation, where you need to validate your model and also interpret the various models. Good. Now, let's start mainly with the machine learning process. As we said, first, you have to start collecting data. So first of all, you need to define your problem clearly. What is your goal? What are your outputs? What output are you trying to predict, right? What inputs, that's the features, might influence that output. Then you decide what type of data you need. Do you need a structured data? Like, do you need a table? And most of the time, machine learning, you need a table of data where you have inputs, types of phones, and the quality, some features of the phones, and then the prices of the phone. So you need some structured data almost every time. Sometimes you may need images, audio for the thing. These are unstructured data. You have to know which data do I need. After you get to know which data you need, then you start collecting such a data, right? Now, in collecting such a data, sometimes some people have already collected some of the data for you. So you can use existing data that is available that people have already collected, and that is faster and cheap, right? Like Kaggle, UCR machine learning repository, Google has data sets, repository that you can go and get data that people have already collected for you. Or you can do the collection yourself, where you conduct some surveys and get the data, or you look through the literature and start gathering the data, or you deploy sensors and at various places to start gathering the data, or you yourself. If you want to tell whether a plant has this disease or not disease, take camera, be taking pictures every day about different plants and their disease type and all that, and you'll be able to get your data ready. Now, when you get your data ready, we have something called data quality. You have to make sure that this data is good, because everything machine learning is the data. That's why data science is also under machine learning, because if the data is not good, we always say garbage in, garbage out, because you want a certain model to learn something. And for them to learn, and you are giving them data which is not good, then you will not be able to learn anything. So you have to check the accuracy of the data, whether this data is good, is it complete, is it consistent, and is in the right format? Is it at the timelines they say, is it up to date? Or is there any bias? Maybe you are grouping data where you want to tell about whether women like food or men like food. And then you have gathered data where 100 of them are men and only 2 of them are women. How will you be able to tell which of them? So we say that thing is biased, right? And you'll not be able to tell. So you have to make sure that there's some uniformity in the data that you have so that you'll be able to make predictions well. And there are some ethical consideration and legal consideration you need to take, especially when you are gathering the data. Let's say you go to a certain website, cannot just go and download the data for Most of them are free. You can download them anytime. Some of them you have to seek permission to get that. And then some of them, there are some privacy laws, and then you have to take from that. And also, the thing should not be discriminatory, right? Like, let's say now, if you tell most of AI models, you tell him to draw a man who is sweeping, they will draw an African. They will not draw a white man because there is bias. Because almost all the things that they use to train people sweeping are African, right? So you realize that sometimes there may be some bias and all that. And these are ethical considerations, legal considerations we are trying to look at in terms of machine learning, so that there will be equity and uniformity, especially when you are dealing with machine learning. Good. Now, after gathering your data, you've structured the data, check the accuracy of everything, you need to decide, now my data is fine. Which one am I using as my input? Which one am I using as my output? So for you to know which one you are using as your output, one thing you should ask yourself what am I trying to predict or classify? And that will be your output. And the common name that we use for that output is target. So most of the time, you don't see me talking about output of the data. I'll talk about the target of the data or the label of the data. And you see, in mathematics, we used to talk about the dependent variable. So that's the output, the dependent variable. Independent variable, the input. Or sometimes say the response, or y. Y equal to f of x. X is the input, y is the output. But that's more mathematical. We'll not be using y and response and dependent variable. Mostly in machine learning, we just be talking about target and label. And these are things we know, right? So target, label. So every time, as you are a machine learning expert now, you should not be saying that this is the dependent variable of my data, or this is the output of my data. But sometimes you can see that. But mainly you want to say this is the target of my data, or this is the label of my data. Then after deciding which one is your output, you have to ask yourself, what information is available to help me make that prediction? That is your input. And here we'll not be calling input, we call it features, or sometimes we call it independent variable. Or most times people who are good in machine learning want to say predictors. What things am I going to use to do that prediction? Called predictors or X. But most of the time we use the keyword features. These are the features of my data. It means that these are the characteristics that will help me make my prediction, right? Then after that, now that you know your input, you know your output. Now your output, you have to decide, am I categorizing or classifying things, or am I predicting quantities, right? If I realize I want to tell whether something is yes or no, I want to tell whether this mail is a spam or it's not a spam, I know I'm doing classification. I want to tell whether the price of a building is 20 cedis or 30 cedis or $30 or $50, then I know I'm doing regression. So your output, after knowing your output, you have to also decide whether you are doing classification or regression work. So now let's as an example, try to tell ourselves whether we'll be able to tell whether something is, which one is my input and which one is my output. So let's say you want to predict customer churn for a telecom company, right? So now the question you want to ask yourself is, what do I want to predict? I want to predict customer churn for a telecom company. So the first thing is, I need to get my data. Let's say you have this data here, and this is the churn for the number of churns for the customers, right? And then the main thing you want to do is you want to tell whether it's a yes or it's a no. That's you want to tell whether somebody will leave the telecom company or he may not leave the telecom company, yes or no. So you have a data of males, females, their age, whether they are doing prepaid or they are doing postpaid, whether their monthly data that they buy every time, the amount of gigabyte they use every time, and everything. And you want to tell whether they will leave or they will not leave. Then the first thing you should ask yourself is, which one is my output? See, oh, the customer churn is my output. Is it a yes or a no? And because it's a yes or a no, I know yes, then I'm doing classification. I'm not doing regression work. So I need classification models, right? Then we have to look at what factors can help me predict this thing, right? You know that, oh, for somebody to leave a telecom company or not, I need whether, is he a male or female? I think that can be a factor, right? His age, because maybe old men don't like data and all that, so they may leave and all that. So we want, okay, age, it should be my input too. The person is using prepaid or postpaid. Does he buy before and all that? can be able to tell. How much I buy every day, oh yes, it can be able to tell me or not. How much gigabyte I use, and then whether I've been in the telecom company for more than 30 years or 20 years, that one should be able to tell. The question is customer ID. Like the customer, his ID is 1001, like your IDs that you have on machine this course. And I want to predict whether you will leave a certain telecom company or you not leave. And I want to know your ID. You realize that your ID does not have any effect on me telling whether you leave this course or you not leave this course, right? So something like ID, you may not consider that as an input. You get the point. So these things are able to tell you which one should be your input, which one should be your output. So now let's see another example that you want to predict how much the customer will spend the next month. So the same data that we have here, but you want to know a certain customer and you want to know how much you will spend tomorrow or next month, right? Now, as soon as the idea comes down, you want to know how much you will spend. You know you are not classifying, you are regressing, right? You are doing regression or you are predicting how much, right? So now, how much you will spend or the monthly bill becomes your output, and your input now becomes the gender, the age, the contract type, data usage, and the tenure. And so these are the things that helps you to know which one is your target and which ones are your features. Let's look at another example. And this one was a trial, but I'm sure because of time, we just want to go through this trial together. Let's say, for instance, maybe you can type in the comment section what you think. That you want to predict, you have this data, you want to predict whether a patient has diabetes or he doesn't have diabetes. You have the ID of the patient, you have age, you have the gender, you have the body mass index, you have the blood pressure, you have the glucose level, insulin, and you have data that tells the family history of the person and whether the person has diabetes or not. Which one is your input? Which one is your output? You can put that in the comment section. You realize that the first thing is, what do I want to do? I want to tell whether a patient has diabetes or doesn't have diabetes. The question is, am I doing regression or classification? There and there, I get to know, yes, well, I think classification. I get to know that that is classification, right? It's not regression work I'm going to do. So I need a classification model for that thing. I need a classification model. So the has diabetes column will be my output, and all the other things will become my input. Now, the next question is, if you want to predict the glucose level of a patient, so look at the column glucose level, and you want to know the level of glucose of that patient. The question is, are you doing classification or you are doing regression? Realize that, yes, you are doing regression. Why? Because you are not telling whether the glucose level is, somebody will say yellow or green. You are rather telling whether the glucose level is 140 or 120 or something. So these are how you identify the inputs. So anytime you are giving your project, try to see which one you are going to use as your input, which one is going to use as your output. And that is all the machine learning as you know them now. Now, I want to predict how much loan a customer will take from a bank. As another last example, how much loan? So you have the age of the person, the income, the employment type, and the credit score. You know, credit score is very important, right? And then the loan the person has been taking, right? And then the long term and the default. Whether the person has not been paying his loan or paid the loan. You have this data, and you want to tell how much loan you want to offer the person. Then what should be your targets? Or the first thing is, are you doing classification or regression? You are doing regression. Why? Because you want to tell the amount of loan to give. So the loan amount is a regression you are going to do. Now, you want to know how much you want to offer that. So what are the things you should use as your features? The age of the person matter, his income level. You want to know how much loan you should give him, right? His employment time. So realize that we can use machine learning anywhere, in hospitals, in finance, in engineering, in anything, any project that I do. All that I need is which one is my input, which one is my output. That's all. A model which we will introduce you to will just do the work and let you know the predictions that you need to make with it. Good one. The last part is you want to predict whether a borrower will default in payment of the loan or he will not pay. Classification. But whether he will pay or not pay. Classification. So these are how to go about your machine learning work. Basically, we've actually looked at almost everything that you actually need to do to get your machine learning work done. So now let's look at the most important part, as I have discussed, which we will introduce you to in the whole course on how to prepare your data very well for machine learning. So you realize that most of the things have to do with how do I prepare my data. After that, I know my features, I know my targets. After knowing my targets and my features, then the data I have, I'm going to split it into two. I'm going to use one to test the model, and I'm going to use one to train the model. So anytime that I show the input to the model and show the corresponding output, you say that you are training it. Just like you are training your child. You show him this is a dog, this is a cat, this is a dog. So the term that we use is training. So you call that set of data your training set. And then after that, you now take your child. So now as you do that, you have built a certain model in the child's brain. And now what you want to do is you show the child a cat and a dog. These are the testing data to test whether the child is going to get that correct or is not going to get that correct. Now, most of the time, before, let's say you are training your child for spelling bee, and you see, you want your child to go and do well. So let's say you are training the child how to spell Kofi. Maybe that's Kofi is what they are going to ask them in the spelling bee. And you have about 1,000 data sets to do or let's say generally I'm just training the child. You have 1,000 data sets to train your child. Most of the time, you don't want to just use 700 to train and use 300 just to test. At least sometimes you want to say that out of the 700 that you are using to test the child, as you test him after some time, you want to go over again and let the person know and confirm whether the person really understood the thing before you go and test him, right? So what you do is we call something the validation set. So sometimes instead of splitting it into training and testing alone, you mostly split them into three. You have the training set, the validation set, and the testing set. So the training set is to test the child. A portion of that data, we will use it to let the child try to confirm that the child really understands the thing before we then go and test the data, which we will be introduced to in one of the courses, how to really separate your data into training sets, validation sets, and testing sets. Now, during the validation process, all that you are trying to do is that you are trying to tune the child's mind to some things, some mistakes that he has been making, right? Because you've not sent him to the testing place yet. We just want to be tuning, so we call something hyperparameter tuning, where we try to let the model be adjusting some predictions that it was trying to make, and then be able to become perfect before we send it for testing. So that's why we have training sets, validation sets, and testing sets. So maybe you have the data, you may want to use 70% of the data to train the model, then you use 15% of it to validate the model before you use the rest of the 15 sets to test the model. Good. Let's come through, we'll finish very soon. Let's come through how we pre-process data, which is very key, and you'll be introduced to in the next two courses, right? So first of all, data, you prepare your data, you need to pre-process the data. You have to make sure that the data is in the right structure before you can know your features and target and be doing whatever that you want to do with it. So we have something called data cleaning, handling missing data, encoding, dealing with outliers, normalization, and the various things that will be introducing you to, right? And this part of it is called data science, because you're just trying to deal with the data, you're just trying to make the data very fine. So in machine learning, you start with data science, right? As you do all your data science right, the rest of the machine learning itself is not any big problem, which you understand. Yeah, that a little coding may be necessary, which we also introduce you to, especially in this course. So you acquire your data, you set your working directory, you import your various libraries, we'll talk about that, you load your data, and the main thing that you want to do is you want to handle missing data. So let's say you've gathered data of types of phone and their prices, and then you realize that some of the data you gathered, the type of phone is not there, but the price is there, right? The question is, can I use such a data for my model that I want to give, right? So some of the data may be missing in the data, right? And I also spoke about there will be some question mark, especially when you're entering the price of the phone. Instead of 30 cedis or $30, the 30, instead of saying 3 and 0, you made it 3 and 0, you made it 3 and O, right? You made it 3 and O. So, or 3 and question mark. So some of the, as I told you, that machine learning just understand numbers, because the computers just understand numbers, right? So everything that is not a number in machine learning, we will mostly be changing them to numbers. And I'll speak about them shortly, very soon. So we want to change everything to numbers. So anything that is not a number in my data that I've gathered, I have to make sure that thing is not part of the data. So I have to clean the data. That's the idea of clean it, make it fresh. or make it look nice, right? Then after that, some things will be missing. Like as I said, the type of phone is not there. You have to be able to try and infer which type was there. Maybe somebody forgot in entering the data, right? Good. And I want to go up one by one, and we will go into detail, especially this area, because mostly takes about 70 to 80% of the work in machine learning. So let's look at data cleaning. Data in the real world are most of the time dirty, it's incomplete, it's noisy, it's inconsistent. Like let's say you have something measuring some data, a sensor measuring some data for you, and the sensor has fault, maybe for a day. Maybe your meter is measuring things, your consumption for your house, so that you make some predictions of your consumption. But then the meter gets a fault, and for a whole day, it didn't send you any data. So you realize that you gathered the data, and today has been missing or is missing from the data. What are you going to do, right? So most of the time, the data is not clean. There are human errors. Maybe you are typing 30, as I said, they make it 3 and O. There are computer errors. As you are typing, maybe you didn't see, and then there are some errors that may come. The sensor is sending the data to your data logger, and the data doesn't get there. Transmission error. So all these things can make data incomplete and dirty. That you need to make sure it's structured well before your machine learning. So noisy data will contain some noise errors, unnecessary characters or outliers, which I'll talk about. There will be missing data. There will be lacking some attributes, lacking certain attributes of interest, and most of the time, your input or your features, sometimes some people say attributes, right? Now, there can be some inconsistency. It can contain some discrepancies in names and sometimes some duplicates, right? So maybe somebody's name came, his age came, and the person's name has come again, his age has come again. So there may be some duplication of the data, which you have to make sure that you remove all those things. Otherwise, your machine learning model will not be able to do anything at all. So how do you deal with noisy data? Always identify non-numeric values. So let's say you see any symbol, @ hash, all these symbols, make sure they are out of your data. So if you have gathered data, so you see all these things is telling you, in case you have to gather data for your machine learning, which you are going to go through, you have to make sure you are not doing some things, right? Especially when you are gathering yourself. You should not be writing 5,000 USD. The computer doesn't know, machine learning doesn't know USD, right? It knows numbers. Yeah, even this 5,000, this comma you're not supposed to bring because it doesn't know comma. It just knows numbers, right? So you should know that at least for points or decimal is known, right? But units, don't be putting units whilst you are gathering. Just put your unit as the heading and make sure you put the names of the things down. Typos can come whilst you are typing. You see, this 1,000, you leave a space. All these things, machine learning will not be able to understand them because it knows numbers, right? Now, you have to decide what to keep or remove. Decimal points, most of the time, we keep. Minus is showing negative numbers, so those ones are mostly there. Dollar signs, commas, all those things you need to remove from your data. And you'll be taught in the next course how to remove all those things, right? How to remove all those things. Good. So let's say I have a certain data here, and then the data I gathered is the one shown here. And this is a problematic data because here I have a dollar. So for me to clean it, I have to make sure this dollar goes away, this comma goes away, then it becomes something like this. 45%, the percentage should go away, kilogram should go away, n/a, sometimes none or blank space, we take them, right? So this is how to clean your data, and you just need some simple understanding of Python, and to be able to remove them once for you. You will not be the one to sit down and be removing this thing one by one. Can you imagine you have 1 million data sets and you have to be removing dollar symbol one by one? You will not finish, right? So that's why we need a little programming, which we also introduce you to. Now, they are incomplete or missing data. Missing value is when your data has empty entries, like now, like none, like blanks, and all that. Data is not always available. Most of the time, any data you go and collect, unless they have cleaned it, some things will be missing. Missing data may be due to equipment malfunction, which I've already talked about. And one thing that you can do is that some of the data that is missing, you can infer, you can make some inferences and get to know that, oh, this was an iPhone that was there, but the price there is not a Nokia 3310, it's an iPhone. So some of the time you can make inferences to know the things that are missing and put them there, right? And one thing too is that you cannot be dealing with this thing one by one, where you are going to look through your data and see, hey, which one is missing? Let me put this one there. This one is missing. And the thing is that if you don't put the right thing, you are going to your machine learning to, because it's going to learn based on what you are going to give it to it, right? So you not just use your head to just be putting something within the data you'll be biased, right? So sometimes you may need to remove the missing data. All the lines or the rows that data are missing, we need to remove them, right? Let's say you have 100 data sets and about, let's say you have 100 rows, and in one of the rows you have about, maybe you have, let me say you have 4 columns, and in the 4 columns, about 3 of the data is missing and only 1 is there. It will be very difficult to predict what the other 3 are. So some of them you may need to remove them. And as you go forward, you may know when you have to remove, when you don't have to remove, right? But maybe you have data where you have 4 columns and 3 of the data are there, but the 4th one is not there. At least you may want to infer what the data is there, because the more data you have, that is what is going to let machine learning be able to do the work well. Because the more data, the more cat and dog you show your child, that's when you'll be able to tell the difference between cat and dog. So data is the most important thing in machine learning. Data, data, data. That's why we talk about something we call data mining. Good. Now you need to fill in the missing values manually, and that's tedious or infeasible. So you have to do that automatically using Python. And sometimes, if you want to fill in some values, there are various something we call value imputation methods that you can use to decide which number is here. Maybe I saw a lot of girls and their heights. Then I know most of the time girls' heights are this. So sometimes you may want to say averagely, this mark is there. Or sometimes you may say, if let's say the people I'm gathering the height of people, and the area there are a lot of short people, right? And few tall people. You may want to use something called the median, because when you organize the data, you have a lot of people who are already short and few people who are, then definitely the middle number will definitely end up being a short person. And you may want to then fix that in there. So sometimes you want to use the median, you want to use the mean. The decision to use some of these things will show you with time, because if you use the median, sometimes it may not give you the right. The machine learning will not be able to understand the thing well, because you made a lot of guess that is not right, right? So sometimes use the mean, it may not be good. You have the mode, like how the example I was giving. You have a lot of people in this a certain category. You may want to use the one that is appearing most. Maybe you are interviewing teachers and doctors in a hospital, right? You realize that in the hospital, mostly doctors that you are going to see, but you saw some 2 or 3 teachers as part of your data. Now, if a column is missing, you want to tell whether it's a doctor or a teacher. Definitely, you know that most of the people here, the mode is the doctor. So let me fix the doctor there. So the decision about the problem you are solving may give you an idea on which imputation method that you have to use. And you have iterative methods that will be able to infer and put the decision there. And as I said, machine learning, I'll be finishing very soon. Machine learning just knows numbers. So if you have list of the type of phone and the prices of phone, and I have to give it to machine learning model to make any prediction for me, I cannot put iPhone, Samsung. Machine learning don't know Samsung. I may need to change Samsung to numbers. I may need to change iPhone to numbers, so that machine learning will be able to decide. And when you are doing that, we use a term called encoding. You are just trying to change the words to numbers. You are encoding. So maybe see something red, green, blue, you want to change them to numbers, then you are saying that you are encoding. You are changing them to numbers. Now, when you are encoding, we are changing some names to numbers. We have various ways so that you can change them to numbers, because sometimes you may not be able to give it any number, right? So we have something called label encoding, where you are just going to give any number, any particular number to. So let's say you have red, green, and blue. You want to say, oh, I want to make red 0, I want to make green 1, I want to make blue 2. And sometimes it's laudable, because it's fine. You just want to give any number. You can actually give any numbers. But the question is that most of the time, when you give numbers like red is 0, green is 2, and blue is green is 1, blue is 2, machine learning may try to understand that blue is more important, because you are giving more weight to blue than red. So sometimes label encoding may not be good, because the machine learning model may think that the data that you have, blue is better than red. That may not be the case. So that's why sometimes label encoding may not be used. We introduce more to these things in the various courses as we are doing. There's something called the target encoding, where we look at what I'm targeting and try to find the mean of the things and put it as the numbers that I want to use to represent the names, right? So using the mean of the target as the various numbers that you want to give to names. And sometimes these two can deviate from the main things, right? So target encoding to have a disadvantage, but some places it may be good. We have something called ordinal encoding, where let's say you have data where there's something small, medium, large. So you realize that you see here the size matter. So if you give it 0, 1, 2, at least it does the work. It says that this is large, it's 2, it's medium, it's 1. So ordinal encoding is sometimes good, especially when you have the ranking of the thing. But if it's red, yellow, blue, you may not need to order them in any way and may want to go with label encoding, but may lead to some mistakes from the machine learning and all that. So the best method most of the time is called one-hot encoding, right? One-hot encoding is most of the best way that we use to change names to numbers in machine learning. And we introduce you to it when we are dealing with the machine learning. One-hot encoding means that, let's say I have red, green, blue, and I want to give them numbers. I have 3 things. So in case I have a column and I have the various names of the, I just have to know the number of names I have there and create that number of columns. So I have 3 things I want to give numbers to. I create red, green, blue as columns. Then anywhere the thing is red, I'll put 1 there and put zeros for the others. And if it is green, I'll put 0 as red and put 1 as green and 0 as blue. You know, when you do this, this is the best way to tell this is red, this is green, this is blue. So anytime my data, I see blue, I know that it's the blue column, I'm going to put 1 there. So this is just the best method, and most of the time, when you are changing your machine learning data from names to numbers, you want to go about one-hot encoding. So, but sometimes ordinal target encoding may be necessary. Then these are the machine learning models. There are various machine learning models that will actually take them one by one and introduce you to them. As I said, we have classification models, we have regression model. I just want us to have just a scan. Linear regression means you have a certain data. As you show the model, so what it means is that you have your data. The model that you are going to give the data to is called, let's say, linear regression, right? And what linear regression is going to do is that when you give him the data and you show him the output, like you give the X and you give the Y, it will try and do a line of best fits, right? So let's try to extend this line. What it means that for a particular X value, I can trace it to this line and I'll be able to predict what the Y is. So basically, that's what linear regression is doing. As you are showing the data, you show the X, you show the Y, you show the X, you show the Y to fit a line. So anytime you want to predict a new thing, which we know about linear regression, it will just fit it to the line and make the prediction. So basically, almost all the models are around this linear regression that we have. Then we have something called logistic regression. Sometimes, if I want to tell whether something is a yes or a no, I will not be able to use linear regression, right? So we have something called logistic regression. We'll introduce you to them so that we'll be able to tell something is a 1 or a 0. Then we have something called decision tree, where we are using the idea of how a tree is and how a tree progresses. Just like here, instead of a tree starting from the leaves to the roots down, we just have to change the name and make it so machine learning and all the AI and all those things. It's not anything. You are just trying to change the names of most of the things that you do and just turn them inside another way. That's why you are here. You get to know the meaning of all of them. Then you know that you are now a machine learning expert. So the root is the one that you start with. And the decision tree, as the name is, you are making decisions. So if you want to tell whether something is a red or a blue, or somebody want to buy a Toyota or a Honda, you realize that, let's say your friend wants to buy Toyota or Honda, you may want to ask him some questions to decide whether you buy Toyota or let me say Toyota or another car, maybe that is 2 car, maybe advertisement. So let me just use it. Maybe let's say Toyota is stronger than another car, and you want the person to decide whether you want to buy Toyota or another car. You may want to ask him, how many seats do you want? And per how many seats you want, you may know, oh, then you need Toyota or you need the other car. Or better still, let me just use a saloon car and we have saloon and a bigger car. So now I want to know whether I want to buy a small car or a big car, right? So I ask you, do you want to buy a small car or a big car? They say, oh, small car. Then I can make a decision for you. Then the next time, the small car, do you need 10-seater capacity or you need 6-seater capacity? I can make another decision. So with such decision from time to time, which basically is based on some simple mathematics behind them, you'll be able to tell whether somebody will buy this car or not buy this car. So that's the idea of decision trees. And we introduce you more to it, especially when you are teaching you decision trees and what they are. Then we have random forest. Like how we have a forest where we have a lot of trees. It's just the same, it's based on the same idea. So you have one tree, then you have another tree, all together makes a forest. So we call it random forest. So you realize that if you are supposed to buy a certain car, whether small or big car, and you have three people that you are supposed to ask, you realize that each of them will have their idea about what you are supposed to buy. So the idea of random forest is so nice because it's just decision tree, but we have a lot of trees. So here, I'm asking this person, and the other person, and based on their views, I can vote and decide. So maybe two of them say buy a big car, then the other one says buy a small car, then I'll know how to buy a big car. So random forest is just an improvement of the decision tree, and we'll be able to make decisions just by some this or this. Is it this one you like or not like? And it's not really based on any serious thing, and you'll be able to. So as we are showing data to machine learning model, and let's say the model you are using is random forest, it will try and make some decisions based on what you do, and then try to rank them to see which one is the best decision for you. And that's random forest. And the almighty artificial neural network we all hear is not any big deal. We'll introduce you to them. Neural network is also, and actually the import of neural network is just linear regression. Just that we don't want to fit only one regression line to one thing. So we want to introduce a lot of neurons to be able to fit that regression line. And as time goes on, a lot of people have brought another idea of not using a regression line, by using a sigmoid function, something called activation function. We'll introduce you to all of them, right? So every neural network is not anything. It's just like how your brain works. If I give you data, that's your input. So you have something called the input layer. Then you have hidden layer. Your brains are hidden. We can't see that one. But then you have an output which you can bring out, right? So we try to connect all the input that you have through the hidden layer and be able to give you an output. And inside these, each of the round things here, we call them neurons. We are going to introduce you to them. It's not any big deal. It's not like your brain neuron. Actually, artificial neural network is trying to look at your brain, but it's far from your brain. Just that the analogy and the things are mainly trying to look at how your brain works. You give your brain an input, the brain tries to think about it and give you an output, right? So we put something we call activation functions. Just like scientists have just seen that anytime somebody gives you an information, when it gets to your brain actually give lights, right? All the neurons in your brain, they actually give some form of light, and based on the light that you'll be able to make decisions and all that. So based on the input I get and the kind of thinking I'm thinking around the thing, I'll be able to make an output prediction. We have something called weights, biases in this neural network that will introduce you to. It's not any big deal. You are going to get them. That's artificial neural network. Then we have something called deep learning. Deep learning, as I said, is a subset of machine learning. So almost all the things I've introduced you to, we call it machine learning. But then, if I'm using artificial neural network in an advanced form, I would say that I'm not doing machine learning, I'm doing deep learning. But actually, it's also machine learning, right? So you can see that this is neural network. We have something called a hidden layer. If I'm using only one layer, I'm saying that I'm doing neural network. But if I'm using a lot of layers, just like how your brain, a lot of layers are there with a lot of neurons, then I'm saying I'm doing deep learning. It's like you are giving the thing, you have few time to think about the thing, neural networks, but then you have a lot of processing things that you are using to go about the thing. We call it deep learning. It's not any big deal. We introduce you to deep learning and be able to understand deep learning. Just neural network. Just that now we have a lot of layers in neural network called deep learning. There's a subset of machine learning that focuses on neural networks mainly. Now, there are various types that we'll introduce you to. We have convolutional neural network, recurrent neural network. These are names. They are basic things that will introduce you to and let you understand, for you to know what convolutional neural network, what recurrent neural network, what transformers are, what the GPTs are, and all that. And most of them, almost all of them, will be using something we call neural network. And that is what we are calling deep learning. So when you look at convolutional neural network, I've shown you how you can know your input and your output. Now, what if you want to tell whether this is a cat or a dog, and then you actually want to use the image, or let me say that you want to recognize somebody's face, whether this is Abraham or it's not Abraham. You need a picture of the person. Now, when you get a picture of the person, you may want to know whether it's the person or not. Your eye is able to tell because every picture has something we call pixels, right? What we do basically is that we cut, let's say the image I took of you is 8 by 8 pixels. What I mean that we just cut the thing into we just cut your image into boxes, right, which are called pixels. And see, in normal machine learning, we will just align all these pictures and give it to our input and through the hidden layer and decide an output. But people have come with the idea that trying to put all the pixels in and give it to the neurons, and then everyone has to learn and all that, to take a long time. So let's do something we call convolutional neural network. We introduce it to something we call filters, try to monitor the very, like, let's say you are looking at somebody's face, you want to tell whether it's him or it's not him. You want to check how his eye is, how his nose is. So this convolutional neural network, by using filters and all that, to be able to tell various edges and various parts of the image and be able to make, and we introduce you to them and realize that it's not any big deal. We do something called pooling, mass pooling, get some feature maps, and then we'll get to a fully connected system and make prediction. We are going to introduce you to it, and you are going to get what convolutional neural network. Now we have recurrent neural network. Realize that if you want to type something online, maybe say apostle, the next thing that will suggest to you is Paul, because so what it means is that if I want to make predictions by looking back on what was being typed, then I have to use something we call recurrent neural network, which will introduce you to it. But sometimes it has, let's say, I want to predict whether there will be, I want to predict time series data, right? I have time series data. Maybe today this happened, the next day this happened, the next day this happened, and I want to make prediction. I can use various models. But if you want to use neural network, mostly you want to go for a recurrent neural network, because that one is able to look at the data before to decide the data that should come after, which will introduce you to. You have transformers. You want to predict like, let's say, as I said, say apostle, the next thing that should come, you need to search through a lot of data to decide whether you have to do this or this. And that one, most of the time, recurrent neural network have some disadvantage. You may want to use transformers, which will also introduce you to in this course. Now, finally, we have something called evaluation metrics, which will also introduce you into this course. As I said, as you train your model and you are testing the model, you need something, a metric, something to evaluate whether the model is doing well or is not doing well. So mostly if it's a regression model, there are some particular metrics we use. And we have a whole course, a whole time that will introduce you to these metrics, because that is what is going to help you judge whether the model you have developed is good or not. You have the mean square error, the root mean square. So most of the time, if you are doing regression work, you will not be saying that the accuracy of my model is this. You will not be talking about accuracies. You will not be talking about precision of your model. You want to be talking about something called mean square error, root mean square, R square, mean absolute error, which will introduce you to the meaning of them and how to interpret whether your model is doing well. Because sometimes these evaluation metrics are the one that will tell you, Charlie, your model is not doing well. Try to do something about the model. Go and tune some things to make the thing better. So we introduce you to evaluation metrics. And then also introduce you to evaluation metrics for classification models. So look at something called confusion metrics, precision, accuracy of your model, F1 score, and all that, which we will dedicate a whole time to let you know what these evaluation metrics are. Now, the next time we are meeting, we are going to introduce you how basically you can use Python to be doing some of these machine learning models. And the nice thing is that we will not really be learning this Python from scratch. We just have some basic understanding of how to use Python, how to add numbers, and how to do some things. People who have sat down, built libraries, something called libraries, just like you enter a library, a lot of books there, right? So most of the things that we want to do in machine learning, people have sat down and built libraries for them. So we'll just be calling them and be using them, and they will just be doing the work for us. Just like if you want to do 1 + 1, those times you have to do a whole coding. But in Python, there's maybe a library called add that can just add numbers for you. You just have to provide the number to add it for you. You don't need to do a whole code to try to add the number. So people have already developed libraries that will help us do all this machine learning work. And most of the time, the simplest of all is the scikit-learn, and there are a lot of libraries on decision trees, KNN, that for beginners, most of the time you want to go with scikit-learn, but it will be to be able to do almost most of the things that you want to do in machine learning. Libraries are there. So if I want to use decision tree, I'll just call decision tree. I don't need to program how to be making the decision. Would it think this way? Will not think this way? The mathematics behind it will not be, I just have to say this. I want to use decision tree. I want to use random forest. I want to use XGBoost, which will introduce you to the various models. So these are nice libraries. You have TensorFlow that was developed by Google, and it's now interfaced with Keras, and we'll be using them, especially when you are doing deep learning. Scikit-learn is not good when you are using them for deep learning, but for normal machine learning, you can be using this scikit-learn. TensorFlow and PyTorch are specially designed, PyTorch developed by Facebook, specially designed for especially deep learning, where you have a lot of data that you want to be having some understanding of them. Other libraries that we'll get to know are NumPy, Pandas. These are normal way of structuring tables and adding numbers that will also be introduced to. And then you also will be introduced to how to visualize your data, right? After everything, you want to do some plot to say, oh, that my prediction is good. You want to do some bar charts, you want to do some regression lines to show that the thing is good, it's not good. You'll be using something called Matplotlib and Seaborn and all the various visualization and reporting libraries in Python already, which will introduce you to them in our next meeting. And this brings us to the end of the class. Thank you very much. Thank you, Tabiri.
Yeah.
Dr. Tabiri, I'm done. Thank you very much.
Yeah, I was wondering if we are going today, but so basically that's the lecture. If you have any question, I will allow just 2 or 3 questions. Most of the questions are in the chat. So Dr. Chumasi will go through them and pick which ones he wants to answer. And if you have any question, please, you can unmute and then ask your question so that he can answer it for you. All right, Adi, if you have any question, please, you can go.
What a very powerful presentation. I just want to know, it looks like the subsequent sessions are going to be quite intensive on the side of the coding and programming. What level of proficiency is required for the next level of, learning that we are going to do?
So,
And if some resources could be recommended to catch up before that.
yes, so this course is for those who have never coded before. So it's for beginners, anyone that doesn't have any skill in coding is welcome, and that's what this course is designed for. So in our next class, the teacher is going to take us through basic skills in coding, all the coding you need to be able to do machine learning, the basics, and they will tell us the structure of things. And the teacher is in this meeting, so he will tell us the structure of things, the softwares that we have to use, and the setup that we have to use. Now, before we come to the next meeting, which is in next 2 weeks, and this is something that we also have to vote on. I'll put a poll in the WhatsApp group for us to determine whether we want to meet weekly or the 2 weeks is fine. Maybe we can do that now. If you want us to be meeting every week so that we can finish early, please put it in the chat. And when we have the poll to, please decide. So the teacher will just, we are going to post the softwares you need inside the group, the WhatsApp group, and I'll possibly email it to you as well. And based on that, you can set up, install the Jupyter and the things you need for the programming class, and just show up here, and the teacher will help us set up a coding environment, and then they will help us go through the basics. You don't need to know how to code to do machine learning. You just have to be taught how to use the code. And the code will be built for you. You just have to plug and play, arrange them like blocks, and to build whatever you want to build. So I hope that answers your question. So don't be afraid. Everybody is welcome.
Okay, so thank you very much for that. And as has been rightly said, it's for us beginning, right? It's for us beginning. It's not going to be scary. We just need to know a little about Python, which will teach you. So by next 2 weeks, most of you should install Python on your machine. Let's go to YouTube.
Everybody is saying next week, so you have to remember.
Next 2 weeks. Next 2 weeks.
No. It should be 2 weeks. It should be 2 weeks.
Everybody in the chat is saying weekly. So we'll revisit that. As people are
just
saying,
go to YouTube and see how I will install Python. Just get that.
The teachers are crying every 2 weeks, and the students are saying every week.
Yes.
No, the 2 weeks, the 2 weeks is important. When you are taught to use 1 week to make sure the
Go
thing is
through.
grounded. Then you come the following week, then you continue.
A lot of weekly here.
Everybody is saying, the students are all saying
Okay.
weekly.
So I think the 2 weeks. So we'll see,
Anyway,
as he said, he sent some polls
we
around
will
and
do the
everything.
polls, and we are serving people, so we just have to give it to them as they want it. But
Yeah,
we'll see.
polls will be sent.
Yeah, we'll
But
table it
yeah,
and
most of the time.
discuss it
So
later on.
yeah, installing your Python and basically how to add numbers in Python, how to do this. We will take you through almost from basics, right? And the thing is that to become, and basically by the time you finish, like I'm sure by today, you have a fair idea of almost everything you need to
Somebody
do.
is saying
The rest,
this is the only place students are saying they want lecture every week. So
yeah, the rest will be we enlightening you on some basic things, somewhere this and this. And very soon, by the time we get to December, and it's just because we are doing 2 weeks, that's why it's December. By that time, you'll be an expert and you'll be able to do all the machine learning that you want to do,
all
right?
right, we have hit
Yeah.
1 hour 30 minutes mark, and we have to close.
Yeah.
We are going to also bring machine learning experts who are professors in the field to do presentation of their work so that you know how machine learning is actually being used in reality. Just as Professor Willie Suboyejo came, the other professors line up who are also going to come to talk to you. So thank you very much, everyone, for coming around. Desmond, if you have a few words, you can put it through. If I've forgotten anything, please go to the yaslinkup.com/the engine to register if you have not registered. Join the WhatsApp group for more information. And next 2 weeks, we are meeting again to look at Python. And we will put the softwares and everything you need before that class in the groups so that you can set yourself up. But thank you very much, everyone. Enjoy your weekend and do have a blessed week. Bye-bye.
Bye.
Send all your questions to the email and we'll get the teachers to answer them for you. Thank you. Bye-bye.
Bye.